Okay, the part came in the wrong orientation, so I have to machine the top side first. So I'm going to line my coordinate system on the part. I'm going to do that by going to World UCS on Geometry, pick Surfaces, Top View, and we'll rotate that around on Z 90 degrees. There we go, something like that. And we're going to line up the coordinate system to the center of the part, top middle. Next, I'm going to create stock. I'm just going to snap to a grid. You could type in dimensions, be more accurate than what I'm going to be, but just for an overall idea. Now I need my part boundary. That's a silhouette boundary. Next I'll make a pocket. Now this is a facing operation where the tool extends beyond the boundary, but with our new high-speed machining toolpath, well, we've changed things up a little bit. Back in the pocket, we want to tell it that we are facing so that the tool does go beyond the stock boundary. Nice even chip load throughout as it cuts into the tight regions. It did not go through here, so it didn't violate it. Let's take a look at what the distance between these tabs are. Somewhere close. So I need an 1/8 inch cutter to get in through there. Now there is another style toolpath we offer, is a helical, spirals in toward the part from the stock, and it looks something like that. Next thing I'm going to do is, rather than draw, let's take a look at our tool. And our tool didn't fit through here, here, and here, so I need to go in. Now in the Express you would have to make all kinds of geometry to cut that. Here we just go to create uncut boundary, and it created that pocket curve for me. So now I'm going to go in with a pocket operation again. Now we have this face here that's recessed into the part. So we make a face curve and we detect the open edges. Every square represents an open edge where the tool can over travel. Notice we don't have any squares along the inside of the part here. Because the curve was generated at the bottom, I can put a depth of 0. It will figure that out for me. What's green has been cut. What we're doing is we're comparing the machining to the model. Anything red is extra stock. So we have yet to do the holes and all the other sides of the part. We have hole recognition. The diameter of the hole. hit the auto button, it knows the depth of the hole. I want my drill body to go to that depth, so I'll just add the drill tip angle, hit the auto again. Next we'll cut this side over here. I don't need to see the other curves, so I'm just going to go and hide those blank. We'll create a new coordinate system. Call this side 1. Line it up on geometry, only circles. Rotate that around X 180 degrees. Okay, this is a little challenging. You have rough material through your stock through here. So I'm going to try to create it with as minimal effort as possible. So I'm going to just take and use a silhouette boundary. I'm going to create a new curve, a copy of that silhouette boundary, and then I'm going to offset it. I'll offset it by maybe 0.275. Generate geometry from both of those curves, and then we're going to delete the curves. I'm going to extend this line out to here, and I want my tool to come into this area, so I'm just going to estimate a section for it to travel to. So I'm going to use line at an angle, snap to screen, come down to about here. Now because I built the curve manually and I didn't extract it from the model, it can't detect what is open. So all these edges over here are open edges for the tool to be able to travel beyond. So I'm going to tell it that. Nice handy tool. And you pick your sections. Each drawing all that geometry by hand. It's not a very big curve, so it's not as bad. Let's find out how deep I want to cut that. Put our cursor down the bottom here. So we're going to go about 375, a little bit beyond. Let's go in with, see what our half-inch tool does for us. And we want to use our side coordinate system. Not bad at all. Failed to remember that we have an oversized tool. So let's find out what that radius is over here. Let's use our 1/8 tool. Come down the spreadsheet. Our 1/8 was tool 2. That's better. Now we need to cut the slots, the side, and these pockets. So let's make a bottom coordinate system. Find out just how deep we need to go. I'm going to put my cursor at the bottom and click. Copy that to the clipboard and paste. Rotate our coordinate system around 180 degrees. Take care of that slot. We'll hide the curve here. Detect open edge. The curve is at full depth, so we don't need to use a depth. It knows it. And we're using the bottom coordinate system. Now we'll machine this side through here. Here we can use our 1/2 inch cutter. I do need to know the depth. So let's grab that. We're going to go that deep. And a couple of things we can do is we can add total stock. We can add stock to it so we take multiple passes up to the wall. And we can tell it that the tool can over travel. So that's an open lead. Okay, we have these faces in through here. Let's use our 1/4 inch tool. So we're going to go in with a 1/4 inch. That'll be tool number 4, I'm sorry. And I'm going to change the coordinate system. Yeah, coordinate system's the bottom, that's correct. So that's another way of editing rather than go into the work step itself. That can be printed out as well. So you can carry a hard copy out to the machine and see what operations you're on and so forth. Depth is 0. Curves are already in location. We had the holes on the side, so we can grab those too. We'll go back. Nice little exemplar exercise for you. So we'll go back to, let's see, there was a side pocket 1. And that was using the side coordinate system. Hole recognition. And I'm just going to take it beyond, go a 1/2 inch deep. There we go. Okay, it looks like we have a chamfer radius around this part over here. Probably could have gone deeper on the other side. So our side, let's go outside side. Let's go 1/2 inch deep. There we go. That concludes this part.